All right, students, this video is going to be a sort of overview of the puppy play area problem. So if you're gone any of the days last week or today, this will definitely help. So assuming you've read the whole setup here, the main idea is 100 feet of fence and a rectangular area. Okay, so the idea then is how much area can we box in there? Okay, so sort of the first step is going to be to make a couple different possible rectangles. So let's make one this like this. And that. And one that's bigger this way and this way. Now, as I say, these are not to scale, so don't worry about them. What we're going to try and do is run the numbers. So like if x was 10, if the width was 10, then you would have 10 and 10 because it's a rectangle. Okay, well if you have 10 and 10, that's 20, and you're using a total of 100, that leaves you only with 80 feet for these, so these have to be 40 and 40. So that's what determines what we got, because you can only go up to 100. So once you've used this much, you're determine what you have left, and that will figure it out for you. Now the area is going to be 10 times 40 or 400 for this one. Okay. Now let's do one of the other ones. 15, for example. 15 and 15. Well, that's used up a total of 30 out of the 100. So that leaves us 70 for these two parts total. If you take 70 divided by 2, you'll get 35 for this side and 35 for that side. So then the area for that, we got to do 35 times 15. And then just go continue like that. Again, don't worry too much about the shape. But if it was 20 and 20, that'd be a total of 40. So that leaves you with 60, which means 30 and 30. Because all four of these together have to add up to 100 feet. Okay, so a couple things here. The area is not the same all the time. It increased there. We'll probably see an increase here. Okay, and that's sort of what we're looking for. So as far as the graph goes, we need the table first. Okay, so that's one of the things. All right. So, what we're going to do for this part, at this part, the whole idea is to get a more generalized formula. And so what it says is, okay, if we have a perimeter formula, 2 lengths plus 2 widths, because that's a length and a length, a width and a width. And then this thing says, if we use the variable x for length, we'll cross that off and call that x now, and x. Then the perimeter is x and x, 2x, and w, 2w. Okay, so right now we still have 3 variables, and that's too many. We don't want that. Well, we decided from the start the perimeter is going to be 100. That's the most fence we have, so we can say 100 equals 2x plus 2w. Or, if we solve this for w, minus 2x minus 2x, we get 100 minus 2x equals 2w. Divide everything by 2, and you get w equals 50 minus x. That's what we're looking for here. 50 minus x was the width. We don't really need that. Yeah, so that was the main idea. So your perimeter equation would have been 2x plus 2w's, but instead of w, so we're just using this formula, instead of w, we're going to put 50 minus x. Again, the advantage here is now we no longer have length and width, we have just one equation with just x. Okay, back to the back side. That's the other key part we need. For here, when you get to the back side, the length we already solved. We said the length was going to be x, and the width we already solved up there was 50 minus x. So your area formula is supposed to be x and 50 minus x. Okay. So that's sort of, in general, the big idea we're trying to go after here. Okay. As far as the graph goes, what you want to do for that, put the x on this one. Area will be on the y. Okay, so your table from the first part, all these points you're going to want to graph. Okay, now a couple things. You can count this one by fives, 5, 10, 15, 20, and so on. But over here, counting by fives is not going to cut it. You need to get at least into the 600s. So you can count maybe by 50s. That might be a good way to do it. 50 to 100, 150, 200, and so on. All right, and if you graph it, it should come out nice and straight. Let me scratch that. Not nice and straight, but actually a nice smooth curve looking like a parabola. So to show you, when you finish it, it should look something like this. So let's zoom in right around there. Okay, so a couple key things here. Your table should have ended up like this. So you can double check your table, make sure of that. And then the points. 525, 10, 400, and it goes up and up until you get to a peak. That's what we were looking for. A side length of 25 gave us a maximum area of 625. Okay, so that's what the graph should have looked like. There are the points, and you should now have everything you need to finish up any of the questions left on there. All right, review this, and hopefully it helps you when we move forward to the volume.